patients and rescuers alike. And as technology and safety systems continues to increase, we can expect to see this problem get worse before it gets better. In Canada, there's an average of over 1,600 MVC incidences every year. About 2,000 of those end up as fatalities. In 2019, Barrier Fire and Emergency Services responded to over 600 MVCs. However, of those 600, about 10% actually required heavy hydraulic extrication. In most cases, hydraulic extrication equipment isn't actually required. Regardless, there are still some basic steps that need to be taken at almost every MVC incident. We're going to take a look at a few of those steps.
These basic steps will help identify what the incident-related dangers are and protect both rescuers and patients alike from collision protection systems like airbags, seatbelt pretensioners, and rollover protection systems, all of which can react violently if not addressed. As with any emergency response situation, one of the first things that need to be addressed is the size up. The size up generally starts before the crew has even left the cab. However, it is predominantly achieved with what is referred to as the circle check. The circle check takes place in two parts. First, we perform an outer circle check, in which we identify hazards that may have caused the accident, as well as hazards created by the accident. In addition, we can use this safe distance to look for hazards that may be contained within the vehicles themselves. Once it's been deemed safe to do so, we can move closer and perform the inner circle check, where we can identify further hazards, as well as the number of patients involved, whether or not airbags have been deployed, or the extent of the vehicle's electrical system, i.e. powered windows, powered locks, and a host of other considerations, such as automatic versus manual transmission. The inner circle check may also be the ideal time to place wheel chocks if needed. Identify your cold, warm, and hot zones early in the size up. These zones will vary depending on the incident and its associated hazards, but generally speaking, the hot zone will be a perimeter that extends at least 10 feet in all directions around the involved vehicles. Stabilization is a crucial first step once size up has been completed to help ensure a safe working environment for rescuers as well as patients. Stabilization is addressed in three parts. The first is scene stabilization. As with size up, stabilization may on occasion start before the circle checks have been completed, as might be the case with downed hydro wires. Once hazards around the incident have been mitigated to the IC's satisfaction, we can start to look at vehicle stabilization and finally patient stabilization. We will look at some examples in the ensuing video, but the basics of scene stabilization may include management of debris or broken glass from the work area, controlling lubricants, hydrocarbons or other fluids leaking from vehicles, and managing damaged utilities such as gas mains or affected hydro poles, and of course, controlling both vehicle and pedestrian traffic. The former can often be managed, at least to some degree, with correct placement of responding apparatus. Also, be sure to stage a fire extinguisher at one of the four corners of the incident, or even better, lay a hose line, either dry or charged as needed. It wasn't long ago that little, if any, consideration was given to chocking the wheels of affected vehicles at an MVC. However, with the advent of hybrid and full electric vehicles, it is often next to impossible to tell if a vehicle's engine is still running. As such, this basic step has become more important than ever. Cribbing the vehicle often consists of what we refer to as 4-point stabilization, but depending on the situation, 6-point stabilization may be required, particularly if the vehicle is resting on its roof. More advanced options include the use of shoring struts, but that's a topic for another day. When placing your cribbing, don't forget to give consideration to patient access and egress. Poorly placed cribbing can impede the openings of a door, for example. Cribbing can also be used to reinforce weak spots, such as the rocker panel below the B-post, when performing a fifth door evolution. Most often, however, our cribbing needs will be satisfied with some well-placed big berthas. In this example, we have 3 pieces of cribbing stacked facing the same direction, which any knowledgeable firefighter, as well as the ensuing video, will tell you is a no-no. However, it is totally permissible with berthas because of the stabilization afforded by the wider base. If still more height is required, we will need to look to box cribbing. All of us are familiar with building the standard box crib. However, don't be afraid to use variations of this standard as the situation dictates. The cross-tie platform, for example, would generally be a better choice if building a crib base for an airbag lift. Other vehicle stabilization considerations need to be given for putting the vehicle in park and applying the parking brake, as well as de-energizing the vehicle's power system to reduce the likelihood of airbag deployment. If the decision is made to cut the battery, ask yourself if managing the power doors, windows, or other power-assisted components will be affected. The last thing you want is to remove the battery only to find out afterwards that you have power seats which now can't be reclined or moved backwards. Finally, we come to patient stabilization. I'll leave Dom and Alex to speak on this in greater depth in another presentation, but due consideration should be given to the golden hour and the need for patient immobilization as dictated by the injuries incurred.
Well, that concludes part 1. Following a short intermission, we'll revisit some old friends and take a look at a video with examples of what we've just been talking about.
The show starts in 1 minute. And now, on with the show.
A simple fender bender or life-threatening entrapment getting off to a good start makes all the difference. Fortunately, in the vast majority of MVCs, those all-important first steps remain a constant, and with only a little variation, you should quickly be on your way to a successful extrication. The purpose of this video is to guide you through an examination of those critical first few steps. An early consideration when responding to an MVC will be truck placement. The truck should be placed so as to provide response personnel with shielding from approaching traffic. In addition, it should be positioned in such a way that a rear-end collision will not propel the fire truck into the emergency scene itself. The captain will decide the type of fire protection needed, a dry or charge hose line, or simply staging a fire extinguisher. With any MVC, a quick and effective size-up and hazard assessment is essential. This is easily accomplished with an inner and outer circle check. The outer circle check will identify patient locations both inside and outside the vehicle, as well as hazards such as hydro lines and leaking fluids. Once safe, moving closer for an inner circle check will provide further information. Is the vehicle in park? Is the engine running? Does it have power seats, power doors, and the status of the SRS system? The circle check is also a good time to commence vehicle stabilization by placing wheel chocks. While this is taking effect, it's a valuable time in which the IC will start to formulate a rescue plan. Once hazards and vehicle information have been passed back to the captain, stabilization can proceed. Stabilization in itself takes place in three separate parts: the scene, the vehicle, and the patient. Scene stabilization has already begun with size-up and circle checks. Once the exterior hazards have been dealt with, we can proceed to vehicle stabilization. This will take the form of a rapid 4-point crib using step chocks, or a 4x4 and a wedge. With trucks and SUVs, box cribbing may be required. More complex forms of stabilization will be examined in later videos. Where possible, place the cribbing along the rocker panel under the frame of the vehicle. Care must be taken with earlier hybrids, however, as this may be where the high voltage cables are located. Cribbing straps should be parallel to the ground, and the rescuer must take care not to place his hands between the cribbing and the vehicle. The rescuer must also note not to place more than 2 pieces of cribbing in the same direction. Doing so may create an unstable base. When building a box crib, it should be no higher than twice the length of a piece of cribbing. 18-inch 4x4s will allow you to build cribs to a height of 3 feet. A single crib will support a load of approximately 24,000 pounds. If greater strength is required, the addition of 1 4x4 per layer will support a load of almost 54,000 pounds. The second part of vehicle stabilization takes place inside the vehicle. If the vehicle is an automatic, ensure it is placed in park. Next, remove the keys from the ignition, reaching above or below the steering wheel, and place them on the dash. At this time, activate the parking brake. Removing keys from the ignition is the first step in airbag mitigation and will initiate a drain on the airbag capacitors. As with disconnecting battery terminals, however, it does not guarantee that airbags will not deploy. Your best protection against airbags is distance. Using the rule of 5, 10, 15, 20, rescuers must try to maintain a distance of 10 inches from the steering wheel, 20 inches from the passenger side dash, 5 inches from the B and C pillars. Curtain airbags can also drop up to 15 inches inside the window. Knee bolsters may also extend 15 inches into passenger leg space. To gain access, a center punch is more effective than a sledgehammer when it comes to tempered glass. Select a window furthest from the patient, place the punch in the bottom corner of the window, and brace your other hand against one of the pillars for support. This will ensure your hand does not go through the window when you break the glass. Once the first window is breached, use protection on the remaining windows to minimize the chance of injury from broken glass. Avoid removing remaining glass with your hands. Use a shield or hand tools where possible. Once patient access is made, it is advisable to continue with glass removal. This will prevent uncontrolled glass breakage later during the extrication process. Where possible, wind the windows down, leaving an inch of glass protruding. Use the glass notch contained on the glass master in a twisting motion to break the window. When cutting a seatbelt, the most common error is to drag the cutter across the belt at a 90-degree angle. Cutting the seatbelt at a 45-degree angle is much more effective. Always check in the glove compartment for the manufacturer's user's manual, which contain information on safety systems and battery locations. When disconnecting the battery, first ensure that power systems such as windows, trunk, door release, and power seat recliners are not required. Disconnect the negative cable first. Make sure the cable does not come into contact with the terminal by wrapping it in electrical tape or cutting it short. Failure to do so can create a spark that may ignite hydrocarbons.